Hello guys, hello guys. In this question, we are going to determine the reactions at the support uh, where the force transmitted through the internal hinge at C. So there is an internal hinge. So we need to find the reaction of EY and EX, and also we need to find the support reaction of AY and AX. Okay. So actually we have four unknowns and we have three equations: summation of moment, summation of Fy, and summation of f of x, plus we have the hinge. So right now it's 4 equal to 4, therefore we need to do by parts. We need to break the structure into two. So let's break the structure. The first, like, try to break it. Okay, so the first one, it's going to be at A. We have two forces of AY and AX, and here we have 6 kilonewton. At B we have on into C, okay, into C, and we have a uniformly distributed load. Okay, so of 0.4 kilonewton per meter, and thus at C it will result two force. The internal load will be Cx and Cy. So we have also four unknowns. Can we find anything? Okay, we actually know that when we split the structure into two, we can do summation of moment at A in order to find Cx, okay, and Cy. Uh, let's say Cx, this Cx1, Cy1. Okay, Cx1 is equal to Cx2, Cy1 is equal to Cy2, since we split the structure into two. So we split the structure only once. Since split the structure into one into two, okay, into two, into two parts. So I split the structure at C, okay, at C, split the structure into two parts. Therefore, you will find out Cx1 is equal to Cx2 and Cy1 is equal to Cy2. Therefore, we need to find the moment at A, and in order to find Cx1 and Cy1. Okay, so you can solve it right here. Okay, and the other part is at C. You have an incline of CD, and you have a column that's connected. Actually, this is called frame. Okay, uh, so let's call this one as frame, and we have EY, and there is EX, and you have an uniformly distributed load of 0.4 kilonewton per meter. Okay, right now you can find the concentration of 0.4 by saying 0.4, okay, time by this length from A to C, it is 20. 0.4 time by 20, 0.4 time by 20, it will found 8. So 8 kilonewton downward, okay, let's say 8 kilonewton downward, okay. uh, see, 8 kilonewton downward. Okay, and you have also here 0.4 times by 20, which will give you 8 kilonewton downward. So let's change the uniformly distributed load into concentrated load. So also you have at C different direction cx2. Okay, let's say cx2, and upward is cy2. Okay, by doing summation of moment at E positive, you will get cx2 and cy2. Therefore you can do simultaneous mode 5 1. By doing simultaneously equation, you can get uh, cx and cy, since cx1 is equal to cx2 and you have cy1 is equal to cy2. Okay, so let's right now start solving it. Right now moment at A, so you have 8 kilonewton downward, and from here to here is 20, therefore the half is 10 meter, and here we have 20 meter. Okay, from here till here is 20 meter, since this is uniformly, and from here to here is also 20 meter. uh, no, since this one is in the middle. Okay, so you have right now cy1, okay, and this it will be concentrated, so I will it will be in the middle, which is 10 meter. Okay, so 8 clockwise time 10 meter, okay, plus cy1 time by 20 meter, and you have plus 6 time by 20, okay, equal to 0. So how many folds do we have? Forget with cy, okay, plus cx1 time by 30. Now how many folds do we have? 1 2 3 4. We have 4 folds. Okay, 1 2 3 4. Okay, 30. This is 20. We have 8 and 2. Okay, so let's try to solve it. 30 cx1 plus 20 cy1 equal to 8 times 10 plus 6 times 20 give you negative 200. Okay, so let's erase these things. Right now here let's do summation of moment at E, which is equal to 0, clockwise positive. So 8 is counterclockwise minus 8 times by same thing, the distance is of 10 kilonewton, which we have 10 kilonewton. Okay, and we have cx2 minus cx2 times by all of these distance, which is from here to here is 10 meter, and from here is 20 meter. Okay, so 10 plus 20 is 30. Okay, and then you have plus cy2 times by its perpendicular, which is 20, okay, and then you have yeah, that's it, equal to 0. So how many first? 1 2 3 3 1 2 3. Okay, So therefore minus 30 cx2 plus 20 cy2 is equal to 80. Let's solve by doing mod 5 1 by doing simultaneous equation. Okay, so mod 5 1 negative 30 we start with 20 80 30 20 and negative 200. So we'll find out Cx is equal to negative 4.67, or we can say which is corresponding to negative 14 over 3 kilonewton. Okay, and you have here Cy which is equal to negative 3 kilonewton. Okay, so right now you can change the sign convection. Instead of the left, you do it to the right. Okay, you will do it to the right, and here instead to the right you will do it to the left, since we say that cx1 is equal to cx2 and cy1 is equal to cy2, which is equal to cy, which is equal to negative 3, even this one cx, which is equal to negative 4.67 kilonewton. Okay, so downward, which is where from negative 3 should be upward actually, since it's negative. This should be upward and this should be downward. Okay, and it will be cx. Okay, just let's mean we finish it. Let's remove, okay, this one, these two. So here cx is 14, so we have here cx is equal to 14 over 3 kilonewton. Okay, and cy, which is the upward, is equal to 3 kilonewton. So we have here cx, which is 14 over 3 kilonewton, and cy here we have equal to 3 kilonewton. Okay, right now we can find the summation of ex, summation of e of x by doing summation of f of y equal to 0 upward. You have ey is upward minus 3 downward minus 8, which is downward, equal to 0. Ey is equal to 11 kilonewton. So we found Ey is 11 kilonewton. Okay, and then we need to find summation of f of x equal to 0. Okay, let's remove this one, positive, therefore minus ex, okay, plus 14 over 3, which is equal to 0. Therefore ex is equal to 14 over 3. Okay, therefore is equal to 14 over 3 kilonewton. Ex is equal to 14 over 3 kilonewton. Okay, or you can say actually, instead of saying 14 over 3, let's say 4.67 kilonewton. Okay, and then you need to go, We finish with this part, okay? Then we need to find the summation of f of y, okay? Let's say the summation at this. Let's assume this is part one and this is part two, okay? Since we split into two parts, let's assume this is part one and this is part two, okay? So in part one, let's say summation of f of y equal to 0 upward, which is positive. So we have ay, which is upward. Then you have negative 8 kilonewton, which is downward. Then you have upward force of 3 kilonewton, okay? This was the result of negative 8 plus 3, which will result of ay equal to 5 kilonewton. So ay is equal to 5 kilonewton. And then you need to go with the summation of f of x equal to 0 positive. So 6 minus cx, which is minus 14 over 3, okay, plus ax equal to 0, okay. So ax plus, okay, so 6 minus 14 over 3, so ax plus 4 over 3, which is equal to 0. Therefore, ax is equal to negative 4 over 3 kilonewton, which we need to change the sign convention of this one. Okay, sign convention should be into left of 1.3. Okay, kilonewton. It's equivalent to minus 1.3 kilonewton. 1.333. Okay, that's it, guys.